Okay, this video is for our first part of 5.4, and we're just going to do the first part, which is adding and subtracting of radicals. And we're going to use similar reducing radical forms that we used in the last couple of tutorials, but we might simplify it and use a different method here and there for a few of them. So what you have to do before you can add or subtract any radicals is that you can only add or subtract radicals that are of the same radical expression. You can only, for example, add things that are all to the root 2 or all to the root 3 or all to the root 4. Just like common adding similar variables, like you can only add a's together or b's together and so forth. So the first thing you have to do is reduce all radicals to their simplest form before you can add or subtract them. So 20 would be the same thing as, well, you can take out 20 is 4 times 5 underneath the root sign. And the root of 4, this would be like 4 times 5 underneath the root sign. There's our perfect square, and there's that one. 3 is like saying 49 times 5. 3 root 250, 245 is like 49 times 5. 49 being our perfect root there. Okay? And we're looking for perfect roots, and here we have another 20. So that's just 4 times 5. So we can take them out now. These are all square roots, so the square root of 4 is 2, so that's 2 root 5. Minus 3 times the square root of 49 is 7. So times 7 root 5. Minus 2 times 2 root 5. So let's simplify out front now. 2 root 5 minus 21 root 5 minus 4 root 5. So now that we can see that they're all root 5s, we can add them or subtract them. In this case, they're all subtracting. 2 subtract 21 is negative 19. Subtract 4 is negative 23. So this would be negative 23 root 5. Okay, and you notice I used a different method to simplify under the root sign by finding perfect squares for that one. And there are other ways to do it using the prime factor method, but we use that in our first section, so I thought I'd change a little bit. So let's look at our second example here now. And let's simplify this first before we can subtract these or add them. This one you can't simplify any more than 3 root 3. Well, 48. Well, what's the perfect root that goes into 48? Well, that's the same as saying 16 times 3, because that's 48. And we did 20s up top, so this would be the same as 4 times 5 under the root sign. And 49, well, we know the root of 49 is an exact number at 7, so we could just say minus 2 times 7. So let's do some simplifying here. 3 root 3. Okay, so minus 2, bring out the square root of 16 is 4, so bring the 4 out. Root 3. And bring the 2 out here because the square root of 4 is 2, so this is minus 6 times 2 root 5. Minus 49. Oh, minus 49. Minus 14, pardon me. Negative 2 times 7 is not 49. It's 14. Sorry about that. Okay, continuing on, we have 3 root 3. This becomes negative 8 root 3. This becomes negative 12 root 5. And this becomes negative 14. So in our example here, we can simplify this part and everything else will stay the same. So this would be negative 5 root 3 minus 12 root 5 minus 14. Okay, and that's, or minus 14. Pardon I almost made another mistake. So now we're going to do another final example here. Let me move my field of view up, make sure we can see there to the bottom. We're going to use a cube root example in this one. Okay, so we're now, instead of taking out groups of 2 or square roots, we're going to have to look for cubes. So I'm going to go back to the prime factor method just in this case. So this one's going to be 3 cube root of the prime factors of 81 are 4 3s. Plus 1/2. And the prime factors of 128, in our case, it's going to be 7 2s. There's my 7 2s multiplied together. Okay, 192 is going to have 6 2s and a 3. Six 2s and a 3. And 54. Pardon me, I need to put the cube roots in here. Let me do that before I forget. Okay, 54. Well, we can do that one as, well, 2. Okay, if we do take 2 out of that, that would become half of that, which would be 27, and then 3 3s. Okay, to make the 27 up. So it's a 2 with 3 3s. So now we can simplify those roots here. So taking pairs of 3s out, this becomes 3 times 3 cube root of 3. I know there's lots of 3s there. This becomes plus 1/2. This would be taking out 2 times 2, which would be 4 cube root of 2, because there's still a 2 under there. This would be minus 3 times, okay, we take out 2 times 2, which is 4 cube root of 3. This one would become, just take out the 3, plus 3 cube root of 2. Do a little simplifying. This would be 9 cube root 3 plus 2 cube root 2 minus 12 cube root 3 plus 3 cube root 2. So we can combine the cube root 2's together to get 5 cube root 2. And we can combine the minus, of course, the cube root 3's, minus 3 cube root 3. And that would be an example of how you add and subtract radicals from that section. Okay. If you had, to the 4th root or to the 5th root, then you're also grouping in 4s or 5s. Just keep that in mind when you're working. In our next tutorial, we'll look at multiplying and dividing.